Hello pre-calculus, and welcome to your video on right triangle trigonometry. This is going to be an exciting one for you guys. So far we've been working with sine and cosine on the unit circle. And we talked in class a little bit. For those of you who've had Tuesday class already, we've talked about this. For those of you who are waiting for Thursday, we'll talk about it on Thursday. But we talked about how this unit circle works. So I'm just going to draw the first quadrant of our unit circle here. Give us a nice little quadrant of this unit circle. And what we did when we were defining sine and cosine is we gave ourselves a point on the unit circle, and then we drew a line connecting the origin and that point. And that point has coordinates at x and y. And so if we have this angle here, and we call this angle t, then if I take the cosine of my angle t, it's going to equal the x coordinate here. And I'm going to do a little sneaky trick and write this as x over 1, which we can do. And I'm going to remind us this hypotenuse is equal to 1. Similarly, if I take the sine of that angle t, that would give us the y coordinate there, which I'm going to write that as y over 1. You might be wondering, why are you doing that? Well, as much as I love the unit circle, we're actually ready to progress past the unit circle and to define sine and cosine in a way where we don't need x and y coordinates. We can just use the triangle. So to do that, I'm going to color up this triangle a little bit to make things clearer. So cosine of t is like our x value here. So remember that x is our x distance, is this leg of the triangle. And we have a sine of t, which is equal to our y value, which is this leg of a triangle. And now you might see why I included 1 as our hypotenuse here. So if I take away the unit circle from our triangle, I'm going to copy the same triangle here. It won't look exactly the same because I'm still working on my artistic skills. But imagine that it's exactly the same perfect triangle that I drew before. So we have the same angle t here. And we still want to know the cosine of t and the sine of t. And we have the same parts of our triangle are the same. So this blue side is the same length as it was before when it was labeled x. And this yellow side is the same length as it was before when it was labeled y. And our hypotenuse is the same as it before when it was labeled 1. So we're going to give these each new names. For this angle t, the yellow side that's directly across from this angle t, we're going to call this the opposite side. The blue side that's right next to it, we're going to call this the adjacent side. And our red side, the longest side of this right triangle, is going to be called the hypotenuse. And now we know that the cosine was equal to our blue side over our red side. Our adjacent over our hypotenuse. And our sine is equal to our opposite side over our hypotenuse. I wonder if you guys can hear my dog panting. I hope it's not too loud. He's sitting on my feet while I record this. And so here we have our hypotenuse in red. And in blue, we have our adjacent side. And in yellow, we have our opposite side. And so we can define the trig functions in this way. We can also build out from this all of the other trig functions we have. Like before, we thought of tangent as being equal to y over x. Well, in this case, y over x is the same thing as the opposite over the adjacent. So we can look at it that way. And then all of the other trig functions that are defined in relationship, we can figure that out fairly easily. So for example, cosecant of t. We know that's equal to 1 over the sine of t, which means we actually take the inverse of sine, and we'll end up with the hypotenuse over the opposite. So that's how this is going to work for us. We're going to be able to do trigonometry and to use these trig functions on any right triangle. On any right triangle. So let's do a couple examples. I think that'll help us. I'm going to show you a couple of examples, a couple ways we can use this that you'll be doing in your homework. That should help. So let's give ourselves a right triangle, but I'm going to draw in a funky position. So here is my 90-degree angle right here. And here's my hypotenuse. So it's in a different position than we're used to seeing, but that's okay. And we're going to talk about this angle alpha here. And so alpha, the opposite side of alpha, is going to have a length of 8. The adjacent side of alpha has a length of 15. And the hypotenuse will have a length of 17. And so what I'm going to want you to do is I'm going to want you to find the cosine of alpha, the sine of alpha, and the tangent of alpha. So go ahead and take a second, pause the video, see what you can get. Welcome back. Time to check your work. So one thing that trips students up here is identifying your opposite and your adjacent sides. It's easy to get those two confused. What I like to do is I like to imagine if I held a flashlight where this angle alpha is and I pointed it straight out in front of me away from the angle, that flashlight would land right on this opposite side. I would cast my light on that opposite side. That's kind of how I know what the opposite is. So that what I've highlighted in yellow there is the opposite. And then the remaining leg is the adjacent. And the longest side is always the hypotenuse. So that's how I'm going to use that information to figure this out. So I know cosine is equal to the adjacent over the hypotenuse. So the cosine of alpha is going to be 15 over 17. The sine of alpha is equal to the opposite side over the hypotenuse. And so we're going to have 8 over 17. And then the tangent is equal to the opposite over the adjacent. And so that is going to equal 8 over 15. And that's how we'll work that out. I know some of you have heard an acronym to remember this. I'm actually going to talk to you about this in class before. There's a very good reason why I'm not going to discuss it in the video. I'm going to give you a new acronym to help you remember these definitions. So it goes like this. Some old hippie caught another hippie tripping on acid. So here's how this works. The definition for sine is opposite over hypotenuse. Sine is opposite over hypotenuse. The definition for cosine is adjacent over hypotenuse. So here I have cosine adjacent hypotenuse. And for tangent, it's opposite over adjacent. And so here I have tangent opposite adjacent. This is just the way students can use to memorize these identities. One of my students last semester came up with it, and I thought it was funny. So now this is the one I use. We can actually do a lot. This is really powerful stuff. We can do a lot of really cool stuff with this. Like, we found some sines and cosines, but we can actually find a lot more information about triangles using all the stuff we know about triangles. Let's suppose I have a right triangle like this. And we're going to say this angle here is angle A. The opposite side to angle A is 7, and the hypotenuse is 25. Suppose I wanted you to tell me We'll name this missing leg x. So let's say we can do a few things in this triangle. We can find x, and we can find the cosine of A and the tangent of A. So the first thing we'll do to find x is we're actually going to use that handy-dandy Pythagorean theorem because this is a right triangle. So here's what we'll do to find x. We'll say x squared plus 7 squared is equal to 25 squared. That's my setup for my Pythagorean theorem. So go ahead and take a second and work this out and come back and I'll show you what I did. All right, here's what I've got. X squared plus 49 is equal to 625. And then I subtract 49 from each side and I get x squared is equal to 576. And when I take the square root of each side, I get x is equal to 24. So now I know this length over here is actually 24. Which means finding cosine and tangent is pretty easy at this point. So let's go ahead and do that. The cosine of A, caught another hippie, is the adjacent over the hypotenuse. Now I know my side that is adjacent to A is 24. So I'll have 24 over 25. And then for the tangent of A, that's some old hippie caught another hippie tripping on acid. So the tripping on acid part tells me that the tangent is opposite over adjacent. So that should be 7 over 24. And that's how we can do that. There's one last thing I want to show you in this video. And this is actually going to turn out to be really cool once we start graphing. It's going to make a lot more sense. But there's something special that I just want to mention called the cofunction identities, because you will work for this on your homework. This kind of stuff will come up. You're going to need these formulas. And I told you guys in class before that all of these trigonometric functions have these beautiful relationships to each other. So these are some true statements. If I take the cosine of an angle t, that's the same as if I took the sine of pi over 2 and I subtracted that angle t. Those two values will always be the same. We also have the tangent of t, which will be equal to the tangent of pi, or sorry, the cotangent. Whoa, that'd be bad. I'd be teaching you guys some lies. The cotangent of pi over 2 minus t. And if I took the secant of t, that would be equal to the cosecant of pi over 2 minus t. So take a look. Now maybe it makes sense why we have the names that we have here. I have sine, then the cosine, and they're related as cofunctions. I have the tangent and the cotangent, and they are related as cofunctions. Right? I hope you're seeing this. I have the secant and the cosecant, and they are cofunctions. That's how they go together. That's how I remember it. And it turns out I gave you the cofunction identities in one direction, but wonder of wonder, it also works out this way. If I take the sine of a particular angle t, that's the same as if I did the cosine of pi over 2 minus t. If I took the cotangent of an angle t, that's equal to the tangent of pi over 2 minus t. And if I took the cosecant of t, that's equal to the secant of pi over 2 minus t. So put these in your notes. These are worth noticing. These are worth using. You're going to use them on the homework. But I also want you to think about why this is true. Think about why these functions have this relationship. We're going to talk about this in class. It has to do with the unit circle, and it's really cool. So that's your hint. Hint, think about the unit circle. And you know what? Think about triangles too. Think about the unit circle and triangles and how we defined all of these functions to begin with. And that can give you your clue as to where these co-function identities are coming from and why they would have this mysterious behavior. I think it's cool. I hope you will too. But that's the only thing we're going to really talk about in this video. Oh, I lied, you guys. I'm so sorry. There's one more example I want to do. My dog was sleeping on my notes, so I forgot to turn the page. And so I want to do an example problem that you might use in the real world. If it were not COVID times, we could do an activity like this in class. It'd be kind of fun. But suppose you're hiking off in the forest. That's something I like to do. And you run across a beautiful tree. And you think, gosh, what a beautiful tree. I wonder how tall that beautiful tree is. You have the ability to solve this using trigonometry. So you want to know, how tall is this beautiful tree? Here's what you can do. You can measure off a distance from the base of the tree. Let's say you walk 30 feet. And then you lay down on the floor, on the ground, out in the beautiful forest, and you eyeball this angle from the top of the tree down to where you're lying on the beautiful forest floor here. You eyeball this angle and you say, this is about 57 degrees. That's my angle. We actually can find the height, because if you notice here, what we've constructed is a lovely little triangle, right? Where H is now the opposite side of our angle of 57 degrees. So what we need to remember is that the tangent is defined as the opposite over the adjacent. And so our opposite value is the height of the tree. Our adjacent side is 30 feet. So if I take the tangent of 57 degrees, I know that's going to have to be H over 30. And I can multiply both sides of my equation by 30 to get H is equal to 30 times the tangent of 57. And your phone calculator can tell you the tangent of 57. You can plug that sucker right in, and you're going to get that the height is about 46.2 feet. And if you guys are good, I'll tell you a real life story where I didn't measure a tree, I measured a building. But I actually had to do some trigonometry in my real life when I was in community college. So make sure to ask me about that in class. It's a funny story. That's all I have for you guys in this video. I hope you are doing well. I want you guys to be staying safe out there and studying hard. You guys are almost there. We're doing well this semester. I'll see you in the next one.